let's talk about the volume of a figure. So earlier, the idea when we calculate the area that bounded by two curves or the area under a curve, we divide the interval in which the area being bounded into small section, and we let the and then we add up the area of the small section to get the area of the bounded region. We use a similar idea here with the volume. To calculate the volume, we split the figure into small region. And so let's say you have a box of some sort. And we say we have a box of some sort. So to calculate the volume of this box, I slide the box, or you think I will slide the box into each of this section. Okay, and let's say I can calculate the area, the volume of each of the slide, the volume of each slide. So volume. If we get the number of those slides go to infinity, then the volume of each of the slide is approximate the area of the cross section of that figure. So that is the idea. Okay, so the volume of the solid integrable cross section area A of x from x equal a to x equal b is the integral of a from a to b. So v equal the integral from a to b of a of x dx. So how do we find the volume using the sliding method? We first examine the solid and determine the shape of the cross-section of the solid. It's often helpful to draw a picture if one is not provided. Then we determine a formula for the area of the cross-section. Okay. Then we integrate the area formulas over the appropriate interval to get the volume. Right? So let's say we divide the formula for the volume of a pyramid. So first, let's draw a pyramid in a way that the center of the pyramid is on the x-axis. So I'll draw this picture. I will make it a little distorted so that we can see what does that exactly look like. So this is y, and this is our x direction. And see, we have our pyramid. Okay, so here's the pyramid. And here we have a cross section because we need to calculate the area of the cross section. Okay, and we call the base of the pyramid length A, and the cross section have the base S, where the height of the pyramid is 8. Right. So let's draw the cross section. What does that exactly look like? Now think about this. This is the we have the xy axis, and the cross of the we take one slide of our pyramid. This distance here, this is the base of the pyramid of length A. The height of the pyramid is this distance is 8. Okay, and the cross section of length S, and the cross section can be vary where it went. So this distance is x. Now that we can see that we have two triangles, right? One made up of the origin, the base of the cross section S, and the other is the origin and the base of the pyramid itself, I can set up the proportion where I say, well, s over a is then equal to x over 8. Then I can solve for s. S is equal a times x over 8. So then the area of the cross section is s squared equal a over 8 squared. And to find the volume, I will take the integral from 0 to 8, the area of the cross section. Note that a and h are number, where x is the variable. So this integration gives us a over 3/8 times x to the third, evaluate from 0 to 8. So this is a over 3/8 times h cubed. That is a times, that is 1/3 a8 squared. And that is the formula for the volume of the pyramid. Okay. Let's say we want to find the volume of this described figure. The base is the triangle with the vertices 0, 0, 1, 0, and 0, 1. And the slice perpendicular to the x-axis are semicircle. Okay, so let's take a look at what it should look like. Let's draw this figure. So here x is y. The base is with the vertices 0, 0, 1, 0, and 0, 1. And so we're looking at this triangle being the base. The slice perpendicular to the x-axis, a semicircle, would mean think about this as it have a circle coming out from the screen, like that. Okay, that is the cross section. So then the area of the cross section is the area of the semicircle. Okay, with the diameter is on that line that connect 1, 1. So we first need to find what is the diameter of the circle. So the cross section is a semicircle, right? And the diameter is the distance from the x-axis to that line that connect 1, 1. So let's create that equation of the line. That equation is y equal 1 minus x. So let's double check that. When x equals 0, y equals 1. When y equal to 0, x also equal 1. Right, so that is our diameter. So the area of the cross section is equal pi r squared. So pi times the rate, so x minus 1 over 2 squared, right? Because that is the diameter divided by 2 to make the radius. Then the volume is measured from 0 to 1 of this integral. And this is pi over 4, 0 to 1 of 1 minus 2x plus x squared dx. So then v equal pi over 4 times x minus x squared plus 1/3 x to the third Evaluate from 0 to 1. That is pi over 12.